In this lesson, we will be discussing counting principles. The objective of this lesson is to determine the number of items in a sample space using combinations, permutations, and occurrences of distinguishable events. From Algebra 2, you learned about sample space. Sample space is the list of all possible outcomes. So what we're doing today is we're not actually listing the sample space, but we're determining how many items are going to be in that sample space. The first thing we're going to discuss is the fundamental counting principle, which is the number of ways that two events can occur is calculated by multiplying the number of times each event occurs. So that's the key thing here, we're multiplying. So for example 1, a combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive is selected. How many different lock combinations are possible? You cannot use the same number twice. So what we're going to do here, the easiest way to do this is to put out 3 spaces for our numbers of selections that we have. We're going to multiply those together, so I put the multiplication in already. The first time we have 30 numbers to choose from because we have the numbers from 1 to 30. After we have used that number, we can't use it anymore, so now I only have 29 options left. After I use that number, I'm now down to 28 options. When I multiply those numbers together, I get 24,360. What I would like you to do now is I would like you to pause the video. I would like you to try example 2 on your own. When you resume the video, I will present you with the answer. If you have the correct answer, then you can skip ahead to the next problem. If not, watch the video and make sure that you have the understanding of how to find the correct answer. The answer for this problem is 6,760,000. So the reason that is, in a certain state, each automobile license plate consists of 2 letters followed by a 4-digit number. So I'm going to make 2 spots for my letters and then 4 spots for my numbers. I'm going to multiply them all together. There are 26 letters in the alphabet. If it doesn't say that we can't repeat, so I'll use 26 again. And then the last 4 are digits. There are 10 digits because we can go from 0 to 9. So we'll multiply 10, 10, 10, 10. And that's how we get the 6,760,000. In permutations, order matters. So when order matters, we're doing NPR, which is n factorial over n minus r factorial. So n is the number of, we'll call them items, and r is the number of items selected. Now, order matters are things where we're lining people up in a row. We're also, order matters if we are assigning people specific jobs, things of that nature. Number 3, in how many ways can 8 children line up in a row? Well, we can use our same method that we did before and just list them all out, 8 times 7 times 6, and so on and so forth. But if we're going to keep going all the way down the line, what we can do is we can do 8 factorial. So 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. When we type that in the calculator, our answer is 40,321. For the next example, we're asked, in how many ways can 15 women finish first, second, and third in the Boston Marathon? No, Miss Brown did not finish first, second, or third in the Boston Marathon, in case you were wondering. Anyway, in this case, this is when this permutation order matters comes in, because we're not ranking all 15 women, so we're not going to do a factorial. Instead, out of the 15 women, we want to know the order that 3 can finish. So it's going to be 15p3. So the math here, n factorial, that's our 15 women, over n minus r factorial would be 12 women. So that's 12 factorial. So really, this is 15 times 14 times 13 times 12 times 11, so on and so forth. For the bottom, 12 times 10 times 9. Well, what happens is the 12 and down on from the numerator cancels with the 12. Apparently, I skipped 11 in the bottom. 12, 11, 10, 9. Cancels with that. So I'm left with just having to multiply 15 times 14 times 13, which gives me 2,730. I would like you to pause the video and attempt the next problem on your own. Once you're done, come back to the video. I'll present you with the answer. If you have the right answer, you can skip ahead. If you did not get the right answer, please watch the example explained so you know how to get the right answer. For this example, the correct answer is 20. We want to know a coin club has 5 members and how many ways can a president and vice president be selected? So out of the 5 members, we're selecting 2 people for jobs. So it'd be 5 factorial over 3 factorial, which would be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. These cancel, so our answer is 20. Distinguishable permutations come into play when we have identical things that we're choosing from. So up here, we didn't have to worry about that because we had 15 different women. We also had 5 different members. So everybody was distinguishable. You could tell everybody apart. In example 6, we're discussing the word Cincinnati. So if we want to put these in different combinations, we run into trouble because there's 2 C's. So we don't know which C is which C. So we would actually have the same thing listed twice. So we want to make sure we take that out. So in order to do this, what we do is we count up the total number of letters in Cincinnati. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the numerator is 10 factorial. For the denominator, we look at the identical sets. So if I look, I have 2 C's. So I'm going to put 2 factorial. If I check, I have 1, 2, 3 I's. So I'll have 3 factorial. Next, I have 1, 2, 3 N's. So that'll be another 3 factorial. And there's only 1 A, so we don't have to list that because 1 factorial is just 1. Interesting fact, 0 factorial is also 1. And I'll explain the reason for that in just a second. Anyhow, when we put this in the calculator, the answer for question 6 is 50,400. Back to the reason why 0 factorial equals 1. If you're doing 0 factorial, like let's say we're talking about a bookcase. If I want to know how many ways I can put 0 things on a bookcase, there's one way I can put nothing on a bookcase, and that's to leave the bookcase empty. So that's why 0 factorial equals 1. Combinations are for when order doesn't matter. So for example, in how many different ways can 2 letters be chosen from the letters A, B, C, D, E, F, and G? The order of the letters is not important. So in this one, it specifically says the order is not important. Another example of this is, let's say, for instance, you have summer reading books. You have to choose 2 books to read. It doesn't matter what order you choose the books to read, so therefore this is a combination. In order to do a combination, it's N and R still stand for the same thing, only there's another piece to the denominator. The extra piece to the denominator divides out those groups that would be the same letters, just in a different order. So when we do this, we have 1, 2, 3, 4, 5, 6, 7 letters all together. We are choosing 2 of those letters. So 7 minus 2 is 5 factorial. Times 2 factorial, because R is 2, we're choosing 2. And when we put this into the calculator, the answer is 21. I would like you to try example 8 on your own. Pause the video. When you come back to the video, I will tell you the answer. If you have the right answer, you can skip ahead. Otherwise, watch the video to make sure you know how to do this problem. The correct answer for question number 8 is 4,845. The reason this is the answer is because we are out of 20 students, we are choosing 4, which would be 20 factorial over 16 factorial times 4 factorial. Now, if you have a calculator, really, you can just type 20C4 in the calculator. And in a different video, I'll show you where all of these buttons are in case you don't know where they are. But really, if you have a calculator, you can just type 20C4. You don't have to do the 20 factorial divided by 16 factorial 4 factorial. If you don't have the calculator, that's when you need to write them out and cancel like I was doing in previous examples. I would also like you to try example 9 on your own. Pause the video. When you come back to it, I'll give you the answer. If you have the right answer, move on. If you don't have the right answer, watch the explanation. The right answer for question number 9 is 99,792. The reason for that answer, we're making a 10-person committee from 9 women and 12 men. The committee consists of 5 women and 5 men. How many different 10-member committees are possible? We're going to do 2 separate combination formulas and then multiply those 2 formulas together. So out of 9 women, I'm going to choose 5. Then I'm going to multiply that by, out of the 10 men, I'm going to choose 5. And then when I multiply those numbers together, I get 99,792. I would like you to try example 10 on your own. Pause the video. When you have your answer, come back. I'll give you the right answer. And then same as before, if you didn't get it right, watch the video. If you did get it right, you can move on. The correct answer to this problem is 24. The reason it's 24, you're at Panera, you have decided to order a soup and a salad with a side. You have narrowed your choices down to 3 soups, 2 salads, 3 soups, 2, apparently I mismatched this question. Hopefully you figured out to just either change salad here to sandwich, or you could leave the salad up there and then change this down here to salad. Okay, hopefully you figured out just make a match. I must have made a typo. Anyway, we have 3 soups, 2 sandwiches or salads, and 4 sides. When we multiply those numbers together, we get 24. You do not have to do the homework right now. When you come into class, you can work with your classmates to do your homework together. That way, if you have any questions, you can go over them together and help each other. Now, because I'm not there, I'm not changing groups. I would like you to stay with your old groups. I do not want you to form groups of your friends. I would like you to stay in your own groups. I will find out, because I always find out, if you made your own groups instead. Please stay in your old groups for the next few days, and we can get new groups in a few days. And also, by any means, I'll be there in the mornings. So if you have any questions, feel free to stop by in the morning and I can help you with